All right, let's go. So you probably attended my talk in the morning. Nice. Let's talk about the underlying technologies for the agents and how to build your own agent. Maybe you want to experiment and try it yourself and see how, let's say, fun it is and how not so simple it is. Basically, what I will be showing here is this, right? I will show you the thing on the left, how to draw an O, like 2 rings, and maybe if you put enough effort, you get a better picture that is on the right. Last year, Anthropic published a couple of interesting news. It's actually so surprising to talk about AI news that are from the last year. Like 6 months ago, right? It's constantly changing, but those 2 articles are a pretty good start if you are interested in the subject. So building effective agents. I know English is hard. Effective doesn't mean efficient, right? So like you have to take this into account. The whole article is not probably so interesting, but it gives you a few pointers. What they have there is these workflows, like basically explaining how we interact with the LLMs and what we can expect. So the very basic idea here is that we can put some command into the LLM and get some kind of a response, either just the response for the problem that we were asking for, or the response might be a tooling call that the model will tell you, hey, to satisfy your query, I need a call from a tool. If you provide me the response from that tool, I can give you the answer, right? Or like using some resources. The model might tell you that you need to store some data on your site for the for the follow-ups, like implementing memory calls, for instance. So that's like a very simplistic workflow here. But I'm skipping half of the article and getting to the very last diagram here. Human can talk to the LLM, and the loop that might be happening on the side between the LLM and the agentic tool will result in this evaluation loop where the results produced by the LLM will be evaluated by something, or the tools might interact with the environment somehow. Let's say interact with the browser, click through your application, get a result, tell to the LLM that the application doesn't actually work, supply some stack trace, collect it from the browser console. Maybe there is a JavaScript error, for instance, and ask it to fix the application automatically. So this loop is what we are looking for in the agentic workflows. Kind of very simplified diagram. And the important part in this are the tools. The tools can be registered programmatically into the workflow, just inside the implementation of the agent, or also Anthropic released last year a specification of the model context protocol that everybody rushed to implement. So it was announced in the end of November, and in January, everybody was already implementing MCP. Even Microsoft implements that inside Windows, some latest updates, right? Which is essentially a JSON RCP. And the initial protocol did not contain anything about the security. So it's interesting how the hype wave made this a de facto standard. Long story short, we have a framework, and we announced it 3 weeks ago. It's a work in progress. You probably don't see it, but it's a version 0.2.1 at this moment. A week ago, it was 0.2.0. 2 weeks ago, it was something else. So, but it's getting a lot of attention by people. It's already more than 1,000 stars in 3 weeks on GitHub. Yeah. That's an open source project. This is what we care about. It's not only the stars, but also the forks, right? So it's a popular topic. Inevitably, people will pay attention, of course, especially if it's announced by the Kotlin team. So what happened in the morning? I was showing you the Juni, the agent. In fact, there is another agent. This is a not real screenshot. It's from the mock-up. It's a work in progress. In fact, there is another agent released already, even for Baba VS Code instead of IntelliJ. So by us, it's just the way things sometimes work. It's going to come into IntelliJ as well. The agent doesn't have a name, so I'm just putting here like JetBrains agent instead. And this is a mock-up. It's not exactly how it will look like, but you can recognize AI Assistant window here, right? So technically, it will be available inside AI Assistant, and we first implemented the agent and then extracted the framework out of that. And now we are moving the agent back to the framework, of course, so that it could be reusable, and then we could battle-proof the solution. The thing is, a lot of problems that the team encounters while implementing the agent are now covered inside the framework. Today, if you're looking for the real implementation or real use cases for the agents, for the AI agents in real life, there are basically two situations: the coding agents, the tooling, and the support agents. This is the only real life application that where agents make sense. Well, they are different kinds, of course. Like support agents can be like for booking the flights, for making appointments, and so on, right? Everything else, what I hear from people is usually I'm hearing them for a few minutes, and then I ask the question: do you really need an agent? Maybe not. Most likely not. And they say, yeah, but management wants us to try. That's a good reason. Anyways, so what I'm going to show you, I said how to draw a null, but I will show you some examples of this framework. And not everything, of course. We don't have that much time. I have the source code in my GitHub account. Whatever I'm showing right now, there is a GitHub for Kug and a special URL for the documentation. I will start my demo actually not from the basics, but from the end, because otherwise we might not make it in time, and you will miss the most interesting things. Let's clear this up. I have IntelliJ running, and I have, let's see, I will make it sure that it's just one instance. Empty project, right? Empty Kotlin project. There is nothing right now. The agent that I have built with the framework is just a jar file. I will execute it from the command line. And just to make it visible somewhat, this is the command line, right? Java minus jar. And then there is a little parameter for myself because I'm experimenting with different models. OpenAI here for the happy path, the quality model that will produce a good result. And then I can experiment with local models because, well, I was trying to make them work. I have a few of them downloaded to my machine. I cannot run all the models. For instance, there are some local models like Llama 4, which is 67 gigabytes, and my machine just doesn't cope with that. Doesn't have enough memory. So I tried with these. Let me execute the agent, and we'll see a lot of output, but I will try to pinpoint those interesting bits. And actually, the interesting part will be happening on the site right there. This is enough, like visible enough for us to see the interaction. So the agent starts, it connects via MCP protocol to IntelliJ. IntelliJ is configured with the MCP plugin. There is a plugins. There is, where is the here? There it is. MCP. There's an MCP plugin that exposes a number of functions from inside IntelliJ as tools to the agent. So if I connect with my agent to IntelliJ, the MCP integration will request for the number of tools. What tools do you have and what they are for? There are descriptors for every tool. And when I make a query to the agent, for instance, write and test a fizz buzz program in Kotlin, as you can see, there's like a lot of, it runs faster than I can stop it. Yeah, but anyways, there's a lot of output, currently debug output, but those are the tools that are available inside IntelliJ. Just for every request, it will, oh, you see, tests are running. Things are happening fast, that's why I'm so hectic, sorry. Because it generated the two files, the program itself, the test, and now it executes the test. If it fails, it's going to try to fix it, but it succeeded because it's a simple program anyway. What do we have now? We have FizzBuzz, we have the test. Nice. And the test succeeded, right? This is the final demo. This is where I want to get. And ideally, I would like to develop a simple agent that is able to work with local models and generate some and test some simple programs, or even just test the programs. Would be nice. Let's go to the sources and, for this boring stuff of exploring the APIs. In GitHub repository, I have the implementation of the agent here, but if you explore it on your own, I have broken that into simple steps, like how can you get started and what bits you can implement. So this is the simplest agent you can have, like the hello world of the agents, right? Because I'm using OpenAI, I have my API key somewhere in environment variables. And to use that, I'm going to use the executor that is tailored for OpenAI. I can, of course, extend the framework and create my own executors, but there are some abstractions already provided by the library out of the box for OpenAI, Anthropic, Google, and some local models as well. Then there is a system prompt where I just say vaguely what the agent is and how it should operate. This is not the best prompt you can think of for the system. A good system prompt should actually describe the workflow, how to do stuff, how to respond, and so on. And there is a model, right? There are some predefined models. I can create descriptors for my own models as well if they are not provided out of the box. That's it. And then, well, tell me a friendly programmer's joke about Amsterdam. A good combination, isn't it? So that's it. Let's run it and see how it operates. So as you can see in the prompt, I tell it, like, once you have the answer, please tell it to the user. That actually is important sometimes. And we might see the result or we might not see the result. Why do you think we don't see the result? It just there is an output for some debug information, but it didn't tell us the joke. That's the joke. That's a good guess. The thing is, to tell the result, it needs a tool. And then we can register the tool registry and run this again. Okay. There's some outputs. Yeah. Why do programmers love Amsterdam? Because they get to work with a lot of damn good engineers. Didn't expect it to synthesize something like this. Just for fun, let's execute another time. It's just interesting, like what could it generate? Have you heard a lot of jokes about Amsterdam programmers? Why do programmers love visiting Amsterdam? Okay. Because it's the only city where you can find great Java free Wi-Fi and canal site views without running into a bug of their code. Okay, well, whatever. By the definition of it, right? Maybe it's just local specifics. I don't know. So that's the hello world. If we don't see the output, I can actually ask it to trace the workflow and how the prompt is handled. Basically, even noisier output for the same hello world application. But there I can also start experimenting with the local models. So currently I have OpenAI and Mistral configured, and by default it's Mistral. So let me run. Is it the same joke? No. Oh, it's the prompt is what are the benefits of using Kotlin for the server side applications? And as you can see, there's a lot of output, and it's basically for tracing because the prompt passes multiple stages inside the agent. You might implement your own workflow that is staged so that at every stage you would have different set of tools available for the model to respond with. And those tools might change on different stage. And basically those stages are organized as a graph, right? So you can predefine the workflow so that please analyze the query, then make the query, then handle the response. If the response is this, then go to that part of the graph. If the response is something else, go to the other part of the graph. Basically organize the logic into this kind of different subgraphs and workflows, and then make it as complicated as you wish. Why cannot I see the cursor? Yeah, it's here. So let's go to another example, the custom tool. So how does the cool tool calling work? When you send the request to the model, in fact, it's part of the API. Most of the models implement that. It's a JSON document that goes into the LLM. In one part of the JSON, you would describe the prompt, the user task, and so on. And then in some other stanza, there would be a list of available tools for executing on the user prompt. So the response from the model would be either just the result, this is what I did, and this is the result, or to implement or to execute on this task, I need to call a tool. This is called this response is called a tooling call, right? So if I receive a tooling call back, it means I need to execute that tool that is integrated that I have available, some kind of a function or a program, anything, and then make another request into the LLM with the result of the tool execution, right? So what is happening there? Again, I have Mistral, I have a system prompt. And if you look into the system prompts for the real agents, along with very generic instructions, there will be something like this, like never do this and do that, but with all caps, important, warning, warning, must do this, and so on. And still, it's not a very good prompt. I could ask the AI assistant to rewrite it for me, and it would come up with something better, more structural, and maybe even the workflow. That's not the point right now, because we are working with very simple things. I can, install tracing. I have tooling registry, and then in the tooling registry, I just have a single function which returns a constant. The reason it doesn't return just 10,000 is because it needs to serialize it structurally, and that is why I have a data class there. So it's built into the framework. But the interesting part is that this is now a tool, and for the tool, I have a descriptor, right? So now when I'm sending the request into the LLM with the tool description, The LLM is now to decide, the tool description seems to match whatever task I need to implement. It seems that I have to generate the tooling call. It will send it back to me, and I will have to execute this function. And this function is registered in tool registry. So basically, we implement the pipeline inside the agent. So let me run it. And I'm currently on Mistral. So it might run, it might not run. And we will see. If it runs, it's interesting. If it doesn't run, it's expected. Hard to pinpoint, but it didn't run. How do I know that it didn't run? Is because I put these things into, like, to see if the function was executed or not. And it seemingly wants to execute the tool, but it couldn't generate a proper response, like the API response. So it didn't happen. What will happen if I switch to OpenAI model? OpenAI. Run. You see the tooling call happened? Yeah, right there. So the current temperature is extremely high, 100,000 degrees Celsius. So because it's probabilistic, I wouldn't be able to show you what happened like half an hour ago. I executed the same query for Mistral as I did just moments ago, and the model hallucinated the tool call within itself and responded that currently the temperature is 23 degrees Celsius. So it was just hallucinating the result within itself, right? The other interesting example that I have here is with the other tool for math. Basically, collecting, it should calculate the sum of numbers, but the task, the way I phrase it, I had 5 apples, I ate 3 apples, my friend gave me 2 apples. What should happen then? Basically, the model should put the right marks, right? +3, -2, whatever. And Mistral was able to generate that once for me, once out of, I don't know, 50 executions. And OpenAI was consistently doing that for every execution. So the quality of the model matters a lot for the tool execution. Let's run it with Mistral. We are out of time already, but I want to show the example here. Let's see. Oh, the tooling call happened. And actually, it was able to figure out the result even with Mistral. So sometimes local models are able to generate the tooling calls properly, the way you expect it, but the prompt matters a lot. So for the local models, you need to fine-tune your prompts, and put more efforts into that, and at least to get this probability a little bit higher. Let me check real quick. Yeah, so this is a better prompt, right? For every task, analyze the request, blah, 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 blah. So one last thing. The workflow, the way it's organized inside the agent, is a strategy. And technically, we describe it as a graph. So we have nodes. In every node, we can define what kind of executions we can do, either to analyze, basically to make a request to the LLM. It can be a tooling node. It can be some custom node to compress your prompts, because you might run out of the context window and so on. So there are different strategies to calculate how many tokens you already have. And then I just described the edges between those nodes and organize them in the graph. And those edges are conditional. So if it's a tooling call, please go to the node execution tool node. If it's just assistant message, like a response from the assistant, from the chat, from the LLM, then go to finish, for instance, right? So it's like a graph with multiple edges, defines the workflow, and I can group those graphs into subgraphs and compose bigger graphs into big workflows, so that my execution of my agent would be more predictable. In the coding agent, I can also give the agent the number of iterations. One second. Where is that? Where is that? Yeah. Max agent iterations, so that I wouldn't run out of my credits like immediately. And this could be configurable, of course. So this framework is kind of a skeleton, but it solves some of the nasty issues like responses with invalid JSON, for instance. So on the back, sometimes you receive the JSON that is broken. Then the framework uses the model either to fix this, or it can have a fallback model for this specific task to make a request, let's say, not to OpenAI, but to something else for doing this task. So there are fallbacks, fixes, parsing, all implemented in the framework. And well, I was able to build a nice coding agent to test Kotlin programs. With this, I'm out of time, and go to my GitHub and play with my samples, and maybe you'll make your own next coding agent, which will, blow everyone's mind. Yeah.
Thank you.
Thank you.
You have 1 minute to join the closing over there.
Yeah, just okay.